Well, hello, class. Today we're going to be talking about speed, velocity, acceleration. You've already done a lot of work on this already, and so at this point, just want to make sure you get down some fundamental notes so that you're able to do the formula to calculate speed, and then we'll go on to kind of experimenting with it and practicing it on your own. Speed is the change in distance over a specific amount of time. You already know this just from seeing speed limit signs on the interstate. And so you see miles per hour, and so that's a distance over an amount of time. And that's all speed is that calculation. So it's really a fairly easy formula for us to do. And here we have it on the triangle. And so speed equals distance divided by time. The same triangle we used for Ohm's law, we can use for speed. Distance is always going to go on top. Speed and time are always going to go on the bottom. So the same way we use that triangle, you use it to figure out the formula you're going to use to find the missing component. And so if you have distance, you're always going to be dividing. If you're looking for distance, you're going to be multiplying the two bottom ones. So let's look at some speed vocabulary, specific speed units that we have. It's measured in units of distance and time. So we have miles per hour. That's the most common one that we have here in the U.S. Meters per second, which is going to be what we're measuring in most of the time. And then kilometers per hour. And so if you were in Europe, this might be the miles per hour signs that we have would be kilometers per hour. So let's look at a speed problem. You have a place on your paper to do this problem and work it out. A baseball was thrown a distance of 60 feet in 0.5 seconds. What is the speed of the baseball? So the way we would do that is distance divided by time to find the speed. So you have 60 divided by 0.5 equals 120 feet per second. Now, why was it feet per second? Because over here, you have 60 feet in 0.5 seconds. So you're going to use the measurements that you have in the word problem to determine exactly what the unit of measurement is there. So let's look at average speed. Average speed is similar to speed, except it's taking the average over an amount of time. And so you can see this graph, and I'll kind of move me out of the way there. On our graph, we have an average speed over time. And there's some things that you see there in the graph. We have a constant speed as a straight diagonal line. And so right here, it's a constant speed. It's going up. As time is going on, distance is being covered. But then we also have a steeper line up here that shows that it's going at a faster constant speed. And so it's going distance in time, but it's going a little bit faster now. And then this straight line right here means it's not going anywhere. You see it stays right at 10 meters the whole time. So it drove to here, and then it stopped for a while, and then it started going again at a faster speed. And so when we look at average speed, the average speed is this all speeds over a given time. This means you're going to take all the different speeds a car was going the entire time they were on a trip, and that's how you would find the average speed. And this is usually what we're talking about when we're talking about speed. Let's look at some examples here. You see the triangle, it's the same thing. The total distance over the average speed over the total time. And so what we're really looking for here is what was the overall speed that you were going on a longer trip, perhaps. So the average total distance over, or I'm sorry, the average speed equals the total distance over the total time. And so there you have the formula. It's a little messed up there, a little out of order, but the triangle is going to be your way to see that the best. So let's look at a problem for average speed. Well, on vacation, Jim traveled 400 miles in 8 hours. And so we want to know what was his average speed during that time. So average speed is the total distance, which is 400 miles, divided by the total time, 8 hours. So if we figure those out, there you go. He was going 50 miles an hour during that time. And that doesn't necessarily mean he was going 50 miles an hour the entire time. He may have been going slower than that at times. He may have been going faster than that at times. But that's the average overall speed of his trip. So let's look at a problem here. Looking at a car in 2 timed trials, we want to know what the average speed during the 2 trials was to the nearest tenth. And so we have trial 1 and trial 2. We have the distance for each one. And so how would we figure that out? Well, average speed equals total distance divided by total time. So distance total over distance time equals average speed. We add up the total distance. We add up the total time. We divide it, and we get the average speed. So there's the specific numbers. There we go. Equals 1.4 meters per second. And so that was the average speed that he was going between those 2 trials. Now, velocity is very similar to speed. It's speed in a given direction. And so all it is you add what direction, north, south, east, west, which way was that object going. And that determines its velocity. Other than that, it's exactly the same as speed. And so you see the triangle is exactly the same. The only thing you have to do is look in the word problem for what direction it was going. So if we look at an example here, I'm sorry, before we get to the example, we'll look at some velocity units. It's measured in the distance and time and direction. And so it'd be miles per hour north, meters per second south. And so those are the units for velocity. It's really pretty simple. Just remember to add the direction. So let's look at a practice problem for velocity. Remember, the same for speed. We're just looking for what direction. So Jane and her mother take a road trip from Houston, Texas to San Francisco, California. It takes 25 hours to make the 1,400-mile trip. What was their velocity? So you got to know a little geography to be able to do this one. Distance divided by time. So the distance was 1,400 miles. The time was 25 hours. And the direction between Houston and San Francisco is west. And that's obviously a little bit general. I guess it'd be northwest technically, but 56 miles per hour west. All we do is add the direction. And so let's look at acceleration. Now, acceleration is a little tricky for us because it's the change in speed or velocity over a specific amount of time. The reason I said that's tricky for us because we don't normally think of acceleration that way. We think of acceleration as going faster. But in reality, acceleration can be going faster, it can be going slower, or it can be changing directions. Any of those things is acceleration. So we think of deceleration, but that's still technically acceleration. You change directions, it's accelerating. So like when you're on a roller coaster at King's Dominion or Six Flags or Hershey or wherever you like to go, that roller coaster is constantly changing acceleration or constantly accelerating because it's changing speed and velocity the entire time. So speeding up, slowing down, changing direction, any of those count as acceleration. So our formula, again, I'm in the way here, so I'm going to move my video, but you can see the formula using our triangle. We have speed divided by time. So acceleration is just going to be speed divided by time. Acceleration and time are at the bottom, speed's at the top, and then we know how to do the math because of where they are in the triangle. I'd recommend to you writing these triangles down beside each one of these. All right, when we look at acceleration units, it's measured in units of speed or velocity per time. So pay attention as we do these. It's a little different. It would be miles per hour, or miles per hour squared. And so we're looking at that speed, and then how much did that speed change over a given amount of time? So you get that per hour. We usually write that as miles per hour squared. Excuse me, meters per second per second. So meters per second squared. These units get a little confusing, but just remember to add that squared because you're looking at the change in speed over time. And so if you have a graph for acceleration, that graph would look like this. You'd have that curved line the whole time there. It's a constant acceleration. It's going to be a curved line. And then an increase in acceleration curves upward. A decrease in acceleration curves downward. So if it's a straight line, that's just looking at speed. But if it's got that curve in it, it's doing acceleration. So as you finish up your notes here, I want you to look at answering these questions. Can you calculate average speed? How do you do that? How do you figure out the speed of any object? And then I want you to describe what's the difference between speed, velocity, and acceleration. Next, you're going to go on to kind of experiment with this, and then you've got a little assessment at the end to see, do you understand speed, velocity, and acceleration? So I want you to go ahead and do those two things. Take the time, do the assessment. Let me check over that. Make sure you understand what you're doing before you kind of close up shop for the day whenever you get to this section. Thanks for working hard, getting through this. Continue to work on it. You get to go out either outside or in the hallway, depending on what the weather's like this day, and kind of calculate some speed with you and about 2 other people in a group. So have fun doing that, and I will check over your assessment when you feel like you've got it done.